today we're going to look at part 2 of lesson 6.6, and the objective that we're going to focus on today. We've been working hard on this first objective in the previous lesson, previous couple of days. We've been looking at the properties and how we can simplify and evaluate expressions. And so today we're going to focus on the knowledge, how the knowledge of those properties can help us solve log equations. And so that's going to be the focus of lesson 6.6 part 2. So this is pretty much going to be the way your homework looks. You're going to be given log equations like letter A, and it's our job to utilize the properties that we've learned to help us solve these. And so the rule of thumb here is there's a couple of things to keep in mind. If you are presented with more than one log in an equation, like we have here, we have 2 logs, then we're going to apply the appropriate property to consolidate multiple logs into one. So that needs to be your first thought. If you have multiple logs, I'll just say combine multiple logs into one. And so we have the product property, the quotient property, and the power property that can all be used to help accomplish this. So for this problem, since these 2 separate logs are being added, I'm going to apply the product property that says 2 separate logs of the same base that are being added can be written as one single log using multiplication. So I'm going to show it like this. Notice I took the log and I wrote it as a single log base 6, and it's going to be of x times, put a little bracket here, x minus 9. Okay, so I'm being a little bit over deliberate so that you can see that these 2 logs became 1 by multiplying x and x minus 9. This is the product property. So now I'm going to go ahead and do that. Log base 6, and now I'm just distributing the x squared minus 9x equals 2. Okay, so I've done this. I've taken the 2 logs, made them into 1, and now I'm ready to change. I'm going to change the equation. It's a log equation now. I'm going to change it to an exponential equation. Okay, so what do I mean by an exponential equation? So I mean something, I'll just put some boxes here. I need a base number raised to some power to equal another number or expression. So this is what I mean by exponential equation form. So we've looked at this. We've done some practicing with this in our previous lesson. I look at the base and notice that the base of the log is 6, so that's also going to be the base for some exponent. Remember, by definition, logarithms are essentially exponents. And so I noticed that if I read this, it would say the log is 2, so that means the exponent is 2. So right away, you can see in exponential form how the base is raised to whatever the log equals. And then this other part on the other side of the equation will be the only other missing piece that we haven't included, x squared minus 9x. So I'm going to write this in exponential form. Of course, 6 squared is 36. And now I'm noticing that this is going to be a quadratic equation. We've had a lot of experience solving quadratic equations, so they need to be made equal to 0. So I'm going to subtract 36 from both sides so that I can solve this. And we've got choices for solving quadratic equations. We can factor, maybe. If factoring is possible, that's what we'll do. We could also use the quadratic formula. We can complete the square. In this case, factoring is possible. So I'm going to show the factored form. of this quadratic trinomial. The factors of negative 36 that add up to negative 9 are negative 12 and positive 3. And so my two solutions, at least I think they're solutions, I need to check and make sure, are 12 and negative 3. So here's the importance of checking your solutions. Remember, we've talked quite a bit how that it is impossible mathematically to evaluate the log of a negative number. We've looked at this in our previous lesson. That can't be done. It's also true that we cannot evaluate the log of 0. It's not possible to raise a number to some power and get a negative result. And it's also not possible to raise a number to a power and get 0. So we need to guard against this happening when we come up with a solution. So you could use your calculator and you can plug in, go back to your original problem, and you can plug in, let's just see what happens if I let x be 12. I got log base 6 of 12, and then I've got log base 6 of 12 minus 9, which is 3, and I want to know if that equals 2. Well, according to the product property, if I put these two together, it would be log base 6 of 36, which is 2. So 12 is a good answer. But negative 3 creates a problem, because if I let x be negative 3, then I've got this situation where I'm trying to do the log of a negative number, which is not possible. So even though I came up with two answers, only one of them is a good answer. This one I'm just going to mark out. It's good that you come down to these two answers, because sometimes both of the answers will work. I'm not saying that all negative answers are bad. It just happens to be that's the case in this problem. All right, so we're done with letter A, so let's try another one. This is letter B. And so once again, look on a side of an equation, and if you have more than one log on a side, combine them into a single log. And so this is going to be an application of the quotient property. Two logs of the same base that are being subtracted can be put together as a single log using division. Okay, so here is another property that we haven't talked about, but we can utilize it in this case. It's called the log property of equality. And basically, here's what it says. If you have logarithms, single logs on either side of an equation, it also works for inequalities, which we'll cover in the later lesson. Today it's all about equations. Do you notice how I've got just one single log of the same base on either side of the equation? So essentially the log property of equality says that what I had before is the same thing as 48 over n equals 6. So if you want to think of the logs cancel each other. Now, again, they have to be single logs, one on each side of the equation, and they have to have the same base for this to be true. So now, really, I'm just solving this equation. 48 equals 6n, and I divide by 6 on both sides, and I get 8. I just want to make sure that that's correct. So let's see. Log base 4 of 48 minus log base 4 of 8. Does that equal log base 4 of 6? According to the quotient property, if I put these two together, it would be log base 4 of 48 divided by 8, which is 6. So that's a good answer. We're ready to move on to the next problem. Okay, similar problem here. I've got two logs that I need to make one, and I'm going to use the quotient property to do that. And I'm going to apply that log property of equality. So really, at this point, just think of the logs being canceled out, and we're just going to solve this. And I multiply by 2 on both sides, and I get x equals 30. And just a quick check visually, it looks like if I put 30 in for x and apply the quotient property, I'm going to get what is given in red. So that's a good answer. All right, let's try this one. Here we're going to need to apply the power property. All right, so numbers like this, when I am trying to consolidate logs or get these into single log form, numbers like this are going to be made into exponents. We've talked about the power property before. Over here, I'm going to apply the quotient property. Since these are both have the same base and they're being added, that means I can put these together using multiplication. So I'll just show that little step there so you'll see where I got it. And 27 times 3 is 81. Now I'm going to apply the log property of equality. So since those are the same base, I can solve this equation. And remember, if I'm solving a quadratic like this, anytime I do the square root of both sides, I have to include plus minus. All right, so let's see, if I go back to the original red equation, can I use both of these numbers? So let's see. 2 times log base 7, 9 equals, and this is going to be log base 7, 27 times 3, which is 81. All right, if I do apply the property, the power property here, I get log base 7, 81. So the positive works. But if I try the negative, I'm trying to do log base 7 of a negative number. So you really have to go back to the original equation as it's given to you in your textbook. So even though I got two answers, only the positive one actually works in this case. But again, there'll be times when the negative does work. All right, let's try this one. I see the product property being used here, so I'm going to put these two together, x and x plus 5. So according to the product property, if I multiply those together, I get x squared plus 5x. Now notice I can't apply that log property of equality in this case because I don't have logs on either side of the equation. So I'm going to change this into exponential form like we did back in our first problem. We took, very similar to this, we took this log equation and we turned it into an exponential equation. Okay, so just think about filling in the boxes. 6 to the second power is equal to x squared plus 5x. This is 36, and since it's a quadratic equation, I need to make it equal to 0. And now I'm going to solve by factoring. And there are factors of negative 36 that add up to positive 5, positive 9, and negative 4. So I get two possible solutions, but I need to make sure that both of them are valid. And based on our previous discussion, negative 9 is not valid because we cannot evaluate the log of a negative number. But it looks like 4 probably does work. Log base 6 of 4, log base 6 of 4 plus 5, which is 9. That makes log base 6 of 36, which is 2. And so 4 is a good answer. All right. And looks like we've got one more. So we've got we cannot join logs together until we take care of these numbers. And so that's what the power property allows us to do. So this would be log base 10 of 8 to the third power. And this will be log base 10 of 36 to the 1/2 power. And then over here, of course, nothing needs to be done yet. Okay, so two logs that are being subtracted can be put together using division. So I'm going to grab my calculator and do 8 to the third power. All right, so 8 to the third power is 512. So putting these two together as a single log base 10, it would be 512 divided by 6. This is the same thing as the square root of 36. And I'm just going to bring down the right side. All right, let's go ahead and simplify this. So in our calculator, 512 divided by 6 is 85.3333. I'll just say 85.33. And now we can simply apply that log property of equality. So these would just cancel each other out. And so my answer is 85.33. Just going to do a visual and make sure that that doesn't create, obviously it's not going to create log of a negative number. So let's just check it real fast. So 3 times log base 10 of 8 minus 1/2 log base 10 of 36. I want to see if that equals log base 10 of 85.33. So in your calculator, it's already programmed as base 10. All right, so all you have to do, if you just key in 3 and then hit your log button and then put in 8 in the parentheses, and then we'll do minus, we'll say 0.5, hit the log button again, and put 36 in parentheses, and let's just hit enter at that point, and we get 1.9311. Okay, so let's see if that equals this on the right side. So again, you don't have to worry about the base 10. It's already programmed for base 10, so just do log, and then in the parentheses 85.33. Now we rounded, so it might be off just a little bit, but looks like it's spot on, 1.9311. So we're feeling good about this answer. All right, and so that's it. That's going to be the assignment for this particular lesson, part 2. So work on those properties and see if you can solve these equations. If you have any questions, let me know.